All right, so we've talked about a new type of operation, quote unquote, you can perform, and that's absolute value, which is basically changing a value from negative to positive and keeping a value positive if it's already positive. So as I said before, we're going to look at what the graphs of absolute value functions look like because they take on a certain shape. But first, the absolute value function is a function that involves the absolute value of a variable. The most basic one would be f of x. Remember, that just means the same as y, but it just represents it's a function, equals the absolute value of x. That's the most basic one. However, we could have some numbers outside the absolute value bars. We could have some numbers inside, but they're all based on this one. Okay? So like another example would be f of x equals absolute value of 3x minus 1. That's going to look a little different. We could do the absolute value of quadratic functions, x squared functions. So how do we go about finding how to graph absolute value functions? Well, it's actually based a lot on what does the graph look like without the absolute value bars? What does the graph look like when you put the absolute value bars in? So let's consider this. Let's say we want to graph the most basic function y or f of x equals absolute value of x. Okay? What I'm going to do is I'm going to graph the function without the absolute value bars. So I'm going to graph y equals x. And what's the best way to start this? Let's do a table of values. So let's pick some negative values. 0 is always a good value to pick, as well as some positive values. We don't need to fill in the whole thing. So if I'm graphing y equals x, and if x is negative 2, what's y? Negative 2. It's the same. So that means negative 2 is a point. If x is 1, y is also negative 1, because y and x are the same. So I get another point. Same with 0, 0. Same with 1, 1. Same with 2, 2. So the graph of y equals x is going to look like this. Now, what if I put the absolute value bars in? What's going to change? So I'm going to do this in a different color. If I plug negative 2 into here, what does y work out to be? Positive 2, right? Because the absolute value of negative 2 is positive 2. So on the absolute value graph, it's negative 2, comma, positive 2. If x is negative 1, the absolute value of negative 1 is 1, so that's negative 1, 1. If x is 0, the absolute value of 0 is still 0. That's the same point as on y equals x. If x is 1, absolute value of 1 is 1. That's also on the same graph as y equals x. And same with 2, absolute value of 2. So the absolute value graph would be part of the y equals x graph, but then it differs on the left side. So on the right side, when x was all positive, the absolute value was the same as without, right? What happened on the left side when x was negative? What happened to all the points when I took the absolute value? Like here, -1. But when I took the absolute value, I got +1. Here, -2. But when I took the absolute value, I got +2. So basically, what's the difference between these two graphs? Well, if you look at the purple one, okay, and if you're going to graph its absolute value, anything that's below the x-axis flips above the x-axis. Okay? So if I gave you this, and then I asked you to take the absolute value of it, well, this part above is the exact same, but then this part below just flips above. That's it. So how do we graph absolute values? We graph them without, and then we go to all the parts below the x-axis and flip them above. Anything that's above stays above. So let's look at another example. And I'm actually going to go to B first before I go to A. So what do I want to do is I want to sketch it without the absolute value bars first. And then put the absolute value bars in to finish it. Do you remember how to graph these ones? This is back from grade 10. Do you remember a certain formula we learned in grade 10 on how to graph lines? Y equals mx plus b. And what do these numbers m and b represent? B is the y-intercept of the line we're graphing. M is the slope of the line we're graphing. So to graph this one, 3x plus 6, the y-intercept is +6 because it's the number at the end. So let's put that on the graph. The slope is 3, but remember, we have to think of slope as rise over run. So I need to write it as a fraction. So what does that mean? From the y-intercept, you rise +3, run +1, which means I go up +3, run +1 means go to the right, and that's a second point on the line. Now that I've got 2 points, just draw the line and try to be as accurate as possible. It should look like that. This is y equals 3x plus 6. I'm not done. Now, I want to put the absolute value bars in. And what does that mean? Everything on graph below the x-axis flips above. Everything above stays the same. So what I need to do everything below the x-axis, I have to flip above. So starting here, it's going to look like this because this point here meets the intersection of grid lines. And so does this one down here. So these ones flip above. But I'm not done. Students will often make this mistake. They'll forget to include this as part of the absolute value. So not only do you have to flip everything above to get part of the absolute value, you also have to take everything that's already above as part of the absolute value. So if I ask you to graph one of these, you've got to make it very clear what the absolute value graph is, using different colors, using a pen instead of a pencil or something. Because if you just do this, and leave it like that, yeah, that tells me that you flipped that above, but it doesn't tell me that you know that this is still part of the absolute value. So you haven't told me enough. This is not sufficient. Okay. Yeah. Whoops. Did everybody graph 3x plus 6? Okay, just change it then. Change it on your question. I made a mistake. So rather than redo the whole thing, let's change it to that. We're fine. Yeah. Yes. Why? Because you sketched it without a ruler? I can't see that from here.
I did this one and then I went to go do this one and it didn't line up at all.
Well, sure it did, because that goes down there.
Well, I just drew the red one here.
Okay, so yeah, but oh, I see. Yeah, so it should have gone down to here.
Okay.
Your original red one. Try to be as accurate as possible. Yes.
Did it just go opposite, like this 3 up and to the left?
Yes, or because it's 3 down here, it goes 3 up there.
Oh, okay, okay.
You can look at it either way.
Okay.
You can look at it either way. Yeah. Okay. So let's just stick with the 3x plus 6. Before we go to the intercepts, what's the domain of the absolute value one? You know this. Negative infinity to infinity. Because it goes left forever and right forever. Range is down to up. And what do I put around the 0? Bracket, right? Okay, for the X and Y intercepts, now, if you do your graph accurately enough, you should be able to read the intercepts off the graph. Okay, so I noticed some of you had difficulty with your original one because you sketched it without a ruler. But just think of it this way. Like, notice that we're going 3 up, 1 across, or 1 across, 3 down. So just think of that to get other points. 1 across, 3 down. 1 across, 3 down. So I'm going to hit right at -2. That's going to be my x-intercept. So if I do from the graphs, or from the graph, the x-intercept is -2. The y-intercept is +6. Remember, we changed it to +6. But you can always do it using algebra. Remember to find the x-intercept, make y equal to 0. So that means 0 is equal to the absolute value of 3x plus 6. Well, since it's 0, I really don't need the absolute value bars. I just need 3x plus 6. So therefore, -6 equals 3x. The x-intercept is -2. Yep.
When you're doing like absolute values, when you have like an equation, you don't change the sign until you get.
We're going to talk about that when we next time. Yeah. The y-intercept, we make x equal to 0. So therefore, y is equal to the absolute value of 3 times 0 plus 6. Well, 3 times 0 plus 6 is 6, and the absolute value is still 6. So you can always find them algebraically, in addition to getting them from the graph. The x-intercept would have been hard to get from the graph if you didn't sketch accurately enough. Okay. That was the reason I did part A last. Okay, last one. The absolute value, or f of x, remember f of x just means the same as y, equals the absolute value of -x squared plus 2x plus 8. So let's skip A for now and go right to the graph. So what we want to do is sketch y or f of x, doesn't matter which one you put, equals -x squared plus 2x plus 8. Make sure I got the right one this time. Yeah. What kind of shape is this graph going to be? A parabola, right side up or upside down? Upside down because it's negative. So we know it's going to look like this somewhere in the graph. Where do we always start when we graph those things? The vertex. Do you remember how to find the vertex of these? Yes? xv equals -b over 2a. And then yv, we just plug xv in back in and calculate. So xv is equal to -2 over 2 times -1 right? I don't feel like I'm right. No, I'm right. Okay. Which does equal one, positive 1. The y vertex will equal negative. Notice the negative is outside the parentheses. Plus 2 times 1 plus 8. So this is going to be 1 squared and then put the negative. Big difference between when the negative is inside and outside when we're squaring. Plus 2 plus 8 gives us 9. So therefore our vertex is 1, 9. There's no number in front of the x squared, so it's regular, which means 1 across, 1 up, or 1 down, 2 across, 4 up, or 4 down. But we also know that it goes down. So it's regular and it opens down. So we go to 1, 9, 2, 4, 6, 8, 9. From the vertex, 1 across, 1 down. From the vertex, 2 across, 4 down. I would suggest you even go again to see where the x-intercepts are. If you go 3 across, how many would you go down? Remember, you're going squared down. So 3 across, 9 down. 3 across, 9 down, which takes you right to the x-axis on both sides. So remember, this is the one without the absolute value bars. Negative x squared plus 2x plus 8. When we do the absolute value, everything below flips above, everything above stays where it is. So everything below flips above. So it flips above in 2 places. Everything above stays above. So the absolute value graph is a little funky looking. It's part of the parabola, but then when it goes below, it flips above. So it almost looks like a little hat almost. What would be the domain and range of those two? Yeah, negative infinity to infinity, and once again, 0 to infinity. That's for the absolute value one. Notice that it doesn't go as high as 9. Don't think that this is the highest, because these 2 arrows here mean it goes up forever in these portions of the graph. And finally, the x and y intercepts. Well, again, if we graph correctly, or as accurately as we can, we could pull them right off the graph. So from the graph, we can see that the y-intercept is what? Where does it cross the y-axis? 8. The x-intercepts, because there are 2 of them, -2 and positive 4. So that's pulling them off the graph. If your graph isn't accurate enough, you can always go to algebra. So to find the y-intercept, we make x equal to 0. So therefore, y is equal to the absolute value of negative 0 squared plus 2 times 0 plus 8. Well, negative 0 squared is 0, negative 0 is still 0, plus 0 is still 0, plus 8 means the absolute value of 8, which means our y-intercept is negative 8, which matches up with what we saw on the graph. The x-intercepts are a little bit more complicated when you do algebra, but you do have the math to do them. You make y equals 0. So therefore, 0 is going to equal negative x squared, absolute value of negative x squared plus 2x plus 8. Because it's 0, we can just take the absolute value bars out. That's the only time we can just take them out. Otherwise, we have to do something else that we'll talk about next lesson. So we get negative x squared plus 2x plus 8. How do we solve that? It's an x squared. Yeah, we got a factor, but what's throwing a wrench in things? The negative. So couldn't I just divide everything by negative 1 to make it a little easier? Well, 0 divided negative 1 is equal to 0 still. And then these just all change signs. So that's a little bit easier when it comes to factoring. And when we do factor, nope, that becomes minus 2x minus 8. I knew I made a mistake there. Yes. Yeah, sorry, I forgot to change them. So factored, I'm looking for two numbers that multiply to negative 8 but add to negative 2. Negative 4 and positive 2. Let's see. Which means that x will equal positive 4 or negative 2, which makes sense because those are the ones we got when we looked off the graph. Okay. So basically for absolute value functions, when you graph them without. So it's either going to be a line or it's going to be a parabola. Put the absolute value bars in by flipping everything below above and keeping everything above the same. And you're done. Okay? Good.